Welcome back, everybody. In this video, we'll be starting up Chapter 2. Chapter 2 continues our look at descriptive statistics, and in particular, we're looking at how we can summarize and look at data graphically. So as always, when we start a chapter, it's a good idea to look forward and see what it is we're getting into before we get into it, and then we'll actually get started. So Chapter 2 has 4 sections in it. Section 2.1 is about frequency distributions and how you can use those to organize and summarize data. And section 2.1 is what this video is about. 2.2 is about a histogram, and a histogram is going to be a pictorial representation, basically, of a frequency distribution. And you can think of a histogram as being kind of like a bar chart that you probably have seen before. Okay, 2.3 is less calculation and more understanding, just simply understanding oriented. It's basically about how you have to be careful at looking at graphs. Sometimes they can be misleading in certain ways, either intentionally or unintentionally. So we're going to take a look at that. And then finally in section 2.4, we're going to look at scatter plots, correlation and regression, which is a quick look at how two variables are related to each other and how that can be visualized. But let's get started for now on section 2.1, which is about frequency distributions. So where we'll start is with a definition and then an example. So a frequency distribution, also called a frequency table, it shows how data are partitioned or grouped into several categories, sometimes called classes, by listing the categories along with the number or frequency of data values belonging to each class. So easy to see by example what it is that a frequency distribution is talking about. And the one shown here is a listing of best actor or best actress, I guess, Oscar winning people for as a function of their age range. So at the age when the Oscar was won, right? So ages 20 to 29, there were 27 actresses in that age bracket. And then ages 30 to 39, there were 34 people. 40 to 49, there were 13 people, and so on. So there's a total of 82 Oscar winners, and they're broken down into these 1, 2, 3, 4, 5, 6, 7 classes according to the age at the time when their Oscar was won. All right, so this is an example of a frequency distribution, and we're going to look at basically some of the important parts of this. We'll continue using this as an example more or less throughout this section. Okay. All right, so here the frequency distribution that you're seeing here is the same as the one on the prior page. I've just kind of marked some important stuff on it. And this part has some more definitions, okay? So for a frequency distribution, the lower class limits are the smallest numbers that can belong to the different classes. So what you're seeing in this frequency distribution, the 20, 30, 40, and so on, all the way up to 80, are the lower class limits. So then the upper class limits are the largest numbers that can belong to the different classes. So that's, of course, the upper end, 29, 39, 49, and so forth. Those will make up the upper class limits. Okay, class boundaries. Okay, this is a little bit more careful. Class boundaries are the numbers that are used to separate the classes, but without gaps. So what is meant by that is this. In between 20 and 29, okay, that's class 1, and 30 and 39, that's class 2. Let's say that a new Oscar was won, and we'd have to say, okay, well, what is the winner's age? And we'd say, okay, well, if she's 24, she would go in class 1. If she's 31, she would go in class 2. At what point do we make the decision to switch from class 1 to class 2? If she's 29, she would be in class 1. If she's 30, she would be in class 2. What if she's 29.4? Okay, if she were 29.4, we would put her in class 1. If she were 29.6, we would put her in class 2. Basically, the halfway point, right, between 29 and 30, which is 29.5, that's going to be the class boundary. So all of these, halfway between 29 and 30 is 29.5, halfway between 39 and 40 is 39.5, and so on. So for this example, as you can see near the bottom of the screen, the class boundaries are 29.5, 39.5, 49.5, and then all the way up to 79.5. Okay. All right, so those are the class boundaries. The class midpoints, as the name implies, are the values in the middle of the classes. So here, for example, halfway between 20 and 29 would be 24.5. And then for the next class, 34.5, 44.5, and so on. To find the class midpoints, you take the average of the upper and lower class limits. So here, 30 plus 39 is 69, and then 69 divided by 2 is going to be 34.5. Okay, you'll notice that the distance between each of the class midpoints is going to be 10, just as the distance between the class boundaries was also 10, 29 and a half, 39 and a half, 49 and a half. So those are the class width. The class width is the distance or difference between two consecutive lower class limits. In this example, it's 10. So again, taking a look back at our distribution, between class 3 and class 4, 40 to 50, that's a difference of 10. Okay, that's the class width. And that's the same as how far apart, like I said, the class boundaries and class midpoints are. Those are 10. You want to be very careful here to remember that the class width is that distance between two consecutive lower class or upper class limits. It's a very common mistake for people to look at an example like this and say, okay, 20 to 29, so 9. Okay, but it's not. If you think about it, count this on your fingers if you like, 20 to 29 is actually 10 years, okay? Because 20 is the first one, and then 1 through 9 would be the other 9. So that's actually 10 years worth of ages, not 9. Okay, so an overall procedure for making a frequency distribution. So if we give you a set of data, how do you make one of these frequency distributions? Basically, you choose a number of classes, and usually it falls between 5 and 20. Just because that's basically usually what happens. There's no rule why it has to be 5 to 20, okay? It's just usually that's what happens. What determines whether it's closer to 5 or closer to 20 is usually how many data values you have. If you only have like, let's say there's like 35 of you in the class, if I'm going to figure out your grades, I'm not going to divide that into 20 classes or subdivisions, right? It doesn't make sense to divide only 35 people, 36 people into so many groups. Plus, with letter grades, it makes sense to divide them up into 5, right? Because there's A's, B's, C's, D's, and F's. So 5 would make sense. On the other hand, if we had something where we were figuring out people's incomes and we were surveying like 25,000 people, then it makes sense to have a larger number of classes or groups. So it depends on how much data you have basically and what it is that you're trying to say. Okay. The class width is the difference between the maximum value in the data set and the minimum value, and is divided by the number of classes. And then we round up. Okay. So to give an example, let's say that we have a set of data that includes the number 8 and then a bunch more because you only take the maximum and minimum, and then 51. Okay, and so that 8 plus 51 is, actually we're subtracting, 51 minus 8 is 43. And then we want to divide by the number of classes. Let's say we want to put that into 4 classes. Let's make it 5 so it's a little more interesting. If we wanted to make that 6 classes, I know I just said 5. All right, so let's say we want to make that into 6 classes. 43 divided by 6 is 7 with a little bit of a remainder. So we're going to round up and call it 8. So we would use 8 for the class width. Okay. You might want to choose the number of classes so that these numbers end up being nice or convenient or easy to work with in some way. Okay, choose the lowest class limit to be the minimum value or some other convenient smaller value. You might want it to start at 0 or some multiple of 5, or you may just want to use the minimum value. Okay, use the class width to get the other lower class limits and the upper class limits. Okay, so here there's some choice, how many classes to use and then you're just kind of rounding up to get the class width. There's no hard rules about this. Basically, your purpose in constructing a frequency distribution is to convey some information, and you want your table to be useful at conveying that information. All right, so let's try an example next. All right, so here's the story for this one. This one is taken out of some other textbook, okay? Here it says, suppose that 40 healthcare workers are taking an AIDS awareness test, and they've earned the following scores on this test. So there's all these scores, and we have 40 of these. So we're going to want to make a ultimately a frequency distribution for this, but there's a lot of numbers here. I know that to calculate the number of classes, I need the maximum and minimum value, and you may not be able to tell this like at a glance. So what we're going to do is to construct a stem and leaf plot to help us organize the data. Okay, so I need to explain to you what a stem and leaf plot is. So here, just taking a look at the data, you can tell that the values are 60s, 70s, 80s. I see 153 in there, but they're mostly 60s, 70s, and 80s. So if we were to read off some of these numbers, let's just take some of the 80s, 87, 84, 82, 82, and then there's going to be some other 80s in there. There's a couple more 80s. In a way, keeping track of the tens digit is almost like extra information. Like if I told you, okay, I'm going to read off the 80s right now, and then the ones digit for one of the scores was 7, then 4, then 2, another 2, a 7 and a 2, an 8 and a 0, a 3 and a 4. Those were all ones digits. And then I've told you, okay, the tens digit is going to be 8, so we don't have to repeat it. So what a stem and leaf plot will do is it will organize that information for us in such a way that we don't have to continually write down those tens digits over and over again. The best way to see how this goes is by doing one. So let's take a look. So as far as tens digits, the smallest tens digits I'm seeing here is a 50. The lowest scores are in the 50s. So I'm going to have one, what's called stem here, because it's like stems of leaves on a tree. The lowest is 5 for 50s, and then they go up to, it looks like 80s. So we'll have 50s, 60s, 70s, and 80s. Okay, so what I'm going to do is I'm going to go through and turn that off one. I'm going to go through and I'm going to write down the scores, but I'm not going to repeat all the tens digits as we run across them. Sorry, one second. I'm going to just keep track of the ones digits. Again, easiest to see by doing. So let's just get into it. So I'm going to scan this thing and I'm going to look for scores in the 50s. So when I find one, I'll write it down and I'll also mark it in my list to make sure that I don't count it more than once. So scanning across the top row, I see a 53 and then nothing else in the first row. In the second row, I'm seeing a 51 and that's it. In the third row, I see a 59 and then a 58. In the last row, I see a 56. And then that's it. So here, there were 1, 2, 3, 4, 5 values in the 50s, but I didn't write down the 5 every time. I wrote the 5 down once, and then all I had to keep track of after that was just the ones digit. So the 3 right here represents 53. The next digit is a 1, so 51. Then 59, then 58, then 56. Okay, so let me try that next for some 60s. So we'll have 62, and then 67. Oops. Then 68. In the second row, we have a 61. then 66, another 66, and that's all. And then in the third row, we have a 61. And the last row, we have a 64. Then a 67 and a 68. Okay, so I can tell at a glance now, one thing is interesting about this, I can tell at a glance now that there's more numbers in the 60s than there were in the 50s. Okay, so now let's try the 70s next. So for 70s, there's 79, and then 76, then 73. Second row, we've got another 79, then 77 and 78, then a 70. Then third row, we have a 76. I can see that I've missed a 64. I'll have to go back and put that in. 76, 77, and that's all for the third row. And then for the last row, I can see there's a 71 and a 74, a 79, and another 79. Okay, let me go back through and put in the 64 that I'd forgotten before. Okay, I've done that. And then finally, all of the 80s. Okay. So for 80s, there's an 87 and 84. And then an 82. And then another 82 in the second row. 86 in the second row. Third row has 87 and 82. And then 88 and 80. Then 83 and 84. All right, so we should have a total of 40 values here. So let me just count those. I won't be sure that there's not a mistake there, but it'll make me at least a little bit confident. So there's 5 in the first row, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 31, 33, 36, 40. All right, so there are 40 values there. And so that's going to make it a little easier for me to organize. I'm going to actually take and rewrite this stem and leaf plot so that the leaves are in ascending order. So let me do that now. All right, so I've sorted our stem and leaf plot so that the leaves are in order. So that's going to be a little bit easier to work with. Fortunately, we're only going to have to do that once. What we're going to do next is construct a frequency distribution for this set of data. And we want to use 8 classes for this. So let's see. In order to do that, we should know the class width. So let's get that. So going back to the prior page, the class width is going to be the range, basically, the maximum minus the minimum divided by the number of classes, and then we're going to round up. So let's see how that will work. So the maximum value was 88, and the minimum is 51. So 88 minus 51 divided by, and we're told to use 8 classes. So 88 minus 51 is 37. So 37 divided by 8 is going to be 7, right? No, 5. What was I thinking? All right, so it's 4 5/8. And so we're going to round it up and say the class width is 5. Okay, and so we need to select a minimum value. So again, going back to here, choose the lowest class limit to be the minimum value or some convenient smaller value. So here my minimum value is 51. And we could use that. But it seems a little funny to start my table at 51 and then all of the consecutive classes will, start with a 1 also. So we don't want to, or the alternate ones will start with a 1. So instead, let me just use 50, okay, instead of 51 for the minimum. So our lowest class limit will be 50. And then the width is 5. So I'm not going to go 50 to 55. Again, remember the width is 5. So it's 50, 51, 52, 53, 54, actually. Sorry, wrong way. So it's going to have to go 50 to 54. I know that looks like it should be 4, but remember the 0th one counts. So the second one will be 55 to, let's think, 55, 55, 56, 57, 58, 59, not 55 to 60. Is 55 to 59. And then the next one will begin at 60. After that, you get a hang of the pattern, right? They're going to alternate in the lower class limits between ending in 0s and 5s. The upper class limits will alternate between ending in 4s and 9s. So 60 to 64. And then we'll have 65 to 69, and then 70 to 74. And then 75 to 79. And then we needed to have 8 classes. So far I've got 6. So let me keep going. So that will be 80 to 84, 85 to 89. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8 classes. And as you can see, our lowest one begins at 50. And so it will be able to include that minimum value of 51. Our highest value was 88, and so that will fit just under the upper limit for our last class. So that's working really well. So let's go ahead and make our table. All right, so I need to count the number of values that are between 50 and 54. So that's going to be the 51 and 53 only, right? So there are 2 of those. Between 55 and 59, this is why having the sorted stem and leaf plot is going to be helpful, right? 55 to 59, that would be the 56, 58, and 59. So there are 3 of them. 60 to 64, there's 1, 2, 3, 4, 5 of those. And then 65 to 69, there's 1, 2, 3, 4, 5, 6 of those. Let me put a divider in here just to organize. 70 to 74, there are 4 of those. 75 to 79, there's 2, 4, 5, 6, 7, 8, 9 of those. 80 to 84, there are 1, 2, 3, 4, 5, 6, 7 of those. And then 85 to 89, there should be 4. Okay, so now let me make sure that the frequencies here should add up to 40, right? So we have 5, 10, 16, 29, 36, 40. All right, so this does add up to 40. And so that is our frequency distribution for this set of test takers. All right, so just to kind of recap what we had done, we made a stem and leaf plot, not because we were supposed to for the frequency diagram, but because our data was unsorted, and so it was kind of disorganized, hard for us to visualize in that way. One thing that this procedure does illustrate is that constructing a stem and leaf plot doesn't cause you to lose any of the data. That is, if we started with this stem and leaf plot, you could recover all of the original data from it. But once you've gotten to the frequency distribution, that abstracts your data to the point where you don't have the original data anymore. For example, let's say you just started a video right here. One thing, you wouldn't know what we're doing, but if you just start the video right here, this class 3 that has a frequency of 5, are those all 60s? Is there a 61 in there? Maybe a couple of 62s? You can't tell just looking at the frequency distribution. But if you go back to the stem and leaf plot, you can say, okay, well, there were 2 scores that were 64. There were no 60s. just as you could get from the original data. So the original data is kind of hard to understand because it's not sorted. Putting it into a stem and leaf plot makes it a little bit easier to understand, and we haven't lost any of the data. The frequency distribution with the 8 classes, that makes it kind of really easy to understand, but we've lost some of the data here. We can't go back to the original data from there. All right, so we'll move on from here. We're going to talk next about what is called a relative frequency distribution. In a relative frequency distribution, each of the frequencies is replaced by a proportion, or like a fraction or a percentage. So here we're going back to our listing of the Best Actress Oscar winning people. And we saw that there were a total of 82 winners. And so what we want to do next is turn each of these frequencies into a percentage. So let me make, for the first one, this will be 27 out of 82. And so that is about 32 point, let me just round to whole percentages, okay? This will be about 33%. Because I'm rounding, this may not total 100%. The next one is 34 out of 82. And that's about 41%. Okay, and then the next one is 13 out of 82. And that's like 16%. Okay, let me go ahead and do these others. All right, so I figured out the rest of the relative frequencies. Having relative frequencies is kind of helpful because it makes it really easy to tell at a glance what proportion or share of a set of data values belongs to a certain class. So you can tell right away that almost half are in class 2, right? Instead of having to think about what 34 out of 82 is, we can just say, well, it's 41%. Okay, so that is a relative frequency distribution. A cumulative frequency distribution. Cumulative is, you can think of like what a cumulative test is, right? Is everything up to a certain point. Cumulative means just that. And a cumulative frequency distribution will add up all of the frequencies for that class and the preceding classes. Okay, so once again, sticking with the Oscar winners, there were 27 people in class 1, that is under the age of 30. In classes 1 and 2 together, that would be everyone under 40. So that one is everyone between 20 and 29 and 30 to 39. So everyone under 40, there's 57, 61 of those. There were 27 in the first class, right? So for the under 50s, that would be everybody in the first 3 classes. So I'm going to take and add all 3 of these together. So that will be 74. And then to add in the next class, there's 2 more, making 76, and then 4 more, making 80. And then in the last 2 classes, there was 1 each, so 81 and 82. So cumulative frequency is basically kind of like a running total through all of the classes. And this makes it easier to answer questions like, you know, how many of the Best Actress Oscar winners were under 50? Okay, 74% or 74 of the 82 were under 50. So that's what a cumulative frequency distribution is. I will leave it to you to figure out what a cumulative relative frequency distribution is. Okay. One thing important to note is that making tables and all of this really can seem like busy work, especially that stem and leaf plot, right? All of that is not the ultimate goal. Understanding the data is ultimately the goal. You should take a look at examples 3 through 5 on pages 46 through 48. And then also go back to our test takers frequency distribution that we made and make a relative frequency distribution and a cumulative distribution and a cumulative relative distribution. All right, so we've done that. All right, so that takes us to the end of section 2.1. In the next video, we're going to take a look at section 2.2. In the meantime, let me know if you have any questions, and have a great day.